All right, 3, 2, 1, and we're live. Okay, here we go. Hello world, it's Siraj, and welcome to my live stream. I am so excited that you're here. Let's see this demo. I want to show you this demo of me snowboarding with the bounding boxes and everything. All right, so let me put that on, and then we're gonna get right into the code. All right, I'm on the ski mountain, and we're gonna take some footage of different snowboarders in my way, and then later on, we're gonna use Yolo object detection to detect where those snowboarders are so that I can avoid them the next time. So this isn't going to be real-time inference. This is going to be just for training data, but then we're going to run inference on our PC. So later on, you know, if we have a Raspberry Pi or some sort of onboard computer on my helmet, we can in real time detect those snowboarders. And then if I have some kind of augmented reality glass, I can see them in real time. But right now, let's just collect some training data, shall we? Here we go. Okay. All right. So that was what I wanted to show you of the snowboarding demo that I recorded, but there's more that I want to talk about besides that. All right. So check this out. Before we start this video on Yolo, the object detection algorithm, there's over 5 versions of this object detection algorithm now. It's the most famous object detection algorithm because it's so fast and efficient. And what you just saw was a video of me, pre-recorded video. I wanted to do it live, but the whole mountain didn't have Wi-Fi everywhere. But it was just me with like the GoPro, and then later on I applied the Yolo algorithm to it to add all those, what you saw, those bounding boxes around people and objects and things that are going to get in the way, aka obstacles. So in this video, we're going to talk about all the different versions of Yolo, how Yolo has evolved, what techniques these computer vision engineers use to improve its accuracy, and then we're going to write out a custom script using Yolo on some image frames just to show you how it works. And we might try it in PyTorch and another language, but I mostly want to just try it in PyTorch because the PyTorch Yolo repo is the best. Okay, so that's what we're gonna do. We're gonna look at the code. I'm gonna have questions for you. Three people are gonna win Bitcoin like always. It's gonna be a lot of fun. But before we get started with that, I just wanna give you a quick update on Code Royale. Code Royale is the game that we've been working on for many months now. It's my startup, my company, my everything, my mission, my gift to this community. And I am extremely committed to it. And I will be talking about it every single week until it's successful. And by successful, I mean we want hundreds of thousands of people around the world to gain employment and to start companies using the knowledge they gain from this free-to-play game, Code Royale. The waitlist is closed. We had over 1,500 signups for that Code Royale waitlist. So if you signed up for the waitlist, you will get early access. But if you didn't get a chance to, don't worry. We'll open it up again in a few months. But right now, for that closed alpha, it's only those initial people. We really want to reward the users in this community, the members of this community that are active and are constantly engaged with the games that I'm playing every week. So that's a little bit on Code Royale. It's going to come out in a month. So hopefully by the end of January, we'll have that released. And I'll be going live every single week until then to continually collect a bunch of winners that we're going to continually promote and glorify for the game. All right. So lots of good things are coming, great things. So I hope you're excited for that as I am. All right. So that's what's going to happen. That was my Code Royale update for you. Now, let's talk about Yolo. The point of this video is Yolo, all right? So where do we even begin with Yolo? First of all, what a great name, Yolo, right? You only live once is normally what it is, but in this case, that's not what Yolo means. In this case, in this algorithmic case, what Yolo means is you only look once. Now, what does that mean in a computer vision context? Let's talk about that for a second. So let's assume that we have this image right here, and this image is an image of a truck. And we can think about this image as a tensor. A tensor is an n-dimensional array, where n is a number of dimensions. And what you're seeing here is a three-dimensional tensor. It's an image where you have an x, y, and z coordinate. You have 600 by 600 by 3, and 3 just means RGB. Those are the three values. And so we have width, length, and then height, but height is just like the color pattern. And so we have this image, and what we want to do is we want to detect all the objects in that image. And that's actually quite a difficult problem, right? That's a different problem from regular old classification. Classification, you just give it an image and it'll say it's a cat or a dog, but it's the entire image. It's not all the different parts of the image. That's a different problem. Classification is easier than object detection. Classification has largely been solved. We get 99% accuracy using convolutional networks. My car literally uses convolutional networks while I don't drive my Tesla on autopilot using 8 cameras. There's no LiDAR, there's no radar, there's no other sensor, just 8 cameras. And it's literally a life or death situation that we are depending on AI for, on convolutional networks accuracy for. So classification has been solved pretty well, but object detection, that's why we need to talk about Yolo, because we still have some improvement to do, even though it's gotten really good. So we take this three-dimensional tensor, this image, and we give it to a convolutional network. And when I say that we give it to a convolutional network, what I mean is that we take that tensor and we apply some set of matrix operations to it, to a network that's already been trained on a bunch of images. Let's say 1,000 different classes, from cats, dogs, planes, birds, what have you. And once we give it to this pre-trained network, be it GoogleNet, ImageNet, ResNet, RetinaNet, whatever pre-trained convolutional network it is, what it's going to do is it's going to output a class probability. It's going to say, just like any other classification CNN, it's going to say, given that image, the highest probability of what you're seeing is a truck by, say, 98%. That's what it's going to normally do. But what we're going to do is we don't just care that there's a truck in that image. We want to draw a bounding box around that truck and any other trucks and anything. We just want to detect all dogs. Maybe there's a car in that image. We want to detect everything. So what do? We take the last layer of that convolutional network before we get to that probability value. And we take that last layer, which contains the most dense, condensed, compressed representations of all of that input training data. And inside of this final layer, that is the key to Yolo. We start with that. We forget about the head of the algorithm, and we discard that, and we just look at that last layer. It's basically a big weight matrix. It's basically a big set of numbers that can be stored in a pickle file, or we can store it in any number of formats. But once we have that last layer, we can convert that final layer, the features in that final layer, into bounding box parameters. And so what I mean by that is that, let's say that this network was trained on faces. The features of that face would be the eyes, the nose, the mouth, the ears, all of those things are features. And when it detects a face, the only way it's going to be able to detect a face is by knowing what all of those facial features are. So inside of its memory, it's encoding these features without us specifically telling it that a face consists of an eye, an ear, a nose. So it's learning what those are over time as it's trained using supervised learning on a labeled data set. But in this case, if we take those features from whatever it's looked at, those features are not going to be an eye, nose, mouth, and ear, because it's not detecting faces. It's detecting, 1,000 different classes. And so that's what you're seeing here, is that if we take an input image and we cut off the end of the network, so instead of giving us one class probability, it's giving us a lot for everything that it thinks that it could possibly be seeing from all the thousands of images that it was trained on. And this can actually be converted into a set of coordinates. And that's what Yolo does, is it takes those final layer features and it converts them into a set of bounding box coordinates, and it overlays them onto an image in real time, just like that. And so, there's going to be a lot of bounding boxes, but a lot of it's going to be noise. So what the initial YOLO algorithm did, you only look once, is it filtered all of those probabilities by class scores. So, the most likely thing that you're seeing in this image is the truck and the car. The other features, it's not as confident about what it is. Like, it might detect a window as a feature, which is a feature of a building, but it's not exactly sure because that image is much smaller than what it's seeing in the foreground, which is the truck and the car. And so that's what it does. And then, after that, it uses this other function called a non-max suppression that we'll get to in a second, which basically says that let's just remove the noise and just have a clear number of bounding boxes. And that's the idea. That's really the simplest way of describing the YOLO algorithm. This is my snowboard, by the way. Basically, I'm a huge snowboarder now. Like, I love this. I am snowboarding every other day. Watch me get good at snowboarding now. But besides that, more than that, I care about machine learning and getting good at my intellect. But you got to have both, right? Train your body, you train your mind. We are a machine. We are a biological machine. You have to become invincible, right? You have to become invincible, both intellectually, develop intellectual calluses by learning these mathematical equations behind YOLO. Yes, it's going to be hard at first. Yes, you're going to stare at it and you're going to say, what is this? But over time, it's going to become easier. You have to build those mental calluses, those intellectual calluses. So you have to become kind of crazy like me, where if you see something really hard, you get excited. You don't get afraid, you get excited. You're like, okay, I really want to learn how this works. And that's how I am with YOLO, because first of all, the name is awesome, the accuracy is awesome, and it's just really popular. And I think it's the best in class object. It is the best in class object detection technique out there. But, it's not something super crazy. It's still just a convolutional network with some other techniques added onto it. But at the core of all of these, it's just the same set of matrix operations, right? ReLU, activation, pooling, convolutional operations, and then you repeat that over and over again for all of these blocks. And that's just the same case for all image-related computer vision tasks that use convolutional networks. They don't even have to use them, but usually the state-of-the-art algorithms in computer vision will use some kind of convolutional network. But that's the easy part. We're just looking at things that are visual. This is a little bit more interesting. This is what I'm talking about when I'm talking about math equations that make me excited. If you can look at this, if you have any idea what this equation is, shout it out in the live chat right now. This is not an official question. That's coming. You better be listening, because I'm going to have an official question coming for you in about 2 minutes. But what this is it's a loss function. And the loss function for YOLO, it's the loss function for the original YOLO algorithm. And it might look like it's a huge loss function, right? Like there's a lot of different things going on all at once. And that's because we are segmenting different parts of the algorithm into different equations, right? So there are different things that we want to find in the YOLO algorithm that are not necessarily going to be embodied in a single equation. So these first two terms that you're seeing up here, these are the localization loss. And then you have the third and fourth terms, which are the confidence loss. And the last term represents the classification loss. So basically, the first math equation is saying where in the image is the class that we're trying to detect. The third and fourth equations are saying how confident are we of that prediction. And then the last equation is saying, what is that classification accuracy percentage? But that's the basic idea. And so this happens all over machine learning, where a loss function actually consists of several other loss functions. What comes to mind for me is like anything having to do with multimodal learning, right? If you have a computer vision and NLP task, maybe transcribe an image, caption a photo, that's a perfect example of you're going to see a huge loss function. Or anything with generative adversarial networks, 100% is going to have a huge loss function with many different parts. So I think that's just something we need to get used to, are big loss functions that involve multiple different subcomponents. They're focused on different tasks within the larger pseudocode, within the larger algorithm. And so there's that. What else do I want to show you before we get into the code? Actually, the first question. The last thing I wanted to show you before we get into the code is, got the loss, and we have one more thing I want to talk about, and that is the area of intersection. So the area of intersection, so the area of intersection, is this image right here, which basically defines this, how is a bounding box computed in the Yolo algorithm? Well, you have this intersection over union, IOU, which is essentially the area of intersection between two bounding boxes divided by the area of union. So it's two areas divided by each other, and the result of those two areas that are divided by each other, why do we even want to do that? The reason we want to do that is because if we do that, then the result is going to be a bounding box that very clearly captures that object that we want to detect, in this case, a cat. But this is used all over the Yolo algorithm, this idea of intersection over union. And so that's the idea behind, that's the highest level behind Yolo. We have a localization loss, we have a classification loss, we have a confidence loss, we have this convolutional operation that's happening, and these bounding boxes are being predicted. And lastly, that all of what I've just said is just for Yolo v1, the first version of Yolo. From then on, more things were added, but what I've just talked about is just the first version of Yolo. And so what that means is that now that we have done that, I'm going to go ahead and ask you the first question. So pull up itempool.com, the custom Play Code Royale web app. It did not work this week, but next week it will work. I really hope so. We're getting so close to it. So we can have a leaderboard and, saved crypto payments for you guys every week. We just want to continually improve this interactive experience for you every week. But in the meantime, let's get to the question. So the first question that I want to ask you on Item Pool this week, we're going to continue using Item Pool. The first question that I want to ask you, let me administer this live. Is okay, so the first question is, let me make that little like that, I guess. Okay. The first question is, which of these computer vision techniques has not been incorporated into Yolo? Is it the localization loss? Is it the convolution with anchor boxes? Is it histogram detection? Or is it bounding box prediction? That is what I'm asking you today. I want to know what the answer was for that. Okay, so that's what I'm going to ask you. Okay. So in the meantime, let me answer some questions here. So what are the questions? The first question is from Suhail Sumra. Suhail asks, can we train Yolo on unlabeled data / unsupervised learning? Suhail, we're going to do that in this live stream. We're literally going to train it on some custom data, and it's going to be awesome. But the answer is no. You need to have some labels. That's just how it is. And even the starting point of Yolo is using labeled data. Those pre-trained convolutional networks are all trained on labeled data. The Coco data set is one. What's another one? ImageNet, but Coco is the biggest one. Related title asks, is Yolo light enough to run on mobile devices real time? Yes, it's literally called Yolo Light. I can't wait to show you that. Literally, if you search Yolo on GitHub, it is Christmas. It is like every gift in terms of there's so many Yolo repositories, Yolo Lite, Yolo V3, Yolo V4, Yolo 9000. There's so many versions of it. Aditya Patel asks, I'm working on an object detection algorithm using Yolo V3. Very cool. That's what I like to hear. With live stream from user browser feed. I'm confused regarding the best possible architecture for end-to-end with deployment. Any suggestions? So okay, from the browser feed. Okay, so the user has a webcam. You want to detect Yolo for end-to-end deployment. That's a really good question. So Yolo is essentially just a convolutional network with some other techniques added on. Sometimes it'll have k-means clustering, or in future versions, or even logistic regression to find the best bounding box. But in terms of in production, what I would want to do is I would create a web app in, say, Django, just to start in Django, Python, just because most versions of Yolo are going to be in Python. And so you just want a full stack solution to start. So it would be a Django web app in Python. And then I would use PyTorch plus like PyTorch serving. At this point, PyTorch has its own, version of TensorFlow serving. PyTorch in production, it didn't before. If it doesn't, then you would switch the model using Onyx. Onyx is the framework for converting different models to work with different models to work with different frameworks, different deep learning frameworks. It's like deep learning interoperability for trained models. So yeah, it would be PyTorch, Django, and maybe add some kind of like authentication flow on top of that, just to prevent someone from like DOSing it or something crazy like that. All right, let's see what the answer was for this question. All right, 3, 2, 1, finish and reveal. Yes, good job, good job. Most people got that this was, in fact, histogram detection. If you were literally listening to everything I was saying, I was literally saying the answers. I was, sneaking them into what I was saying to you. So great work if you got that. I'm very proud of you, and you absolutely get your own sound effect. Go. Boom. Yeah. All right. So good job with that. Let's keep going here. Now we're going to get to the code. Let's like build some YOLO now. So we will now build some YOLO. And what else? We're going to build some YOLO. All right. So let's take a look at GitHub. Let's take a look at the YOLO repositories that we've got, and then we might just want to write our own custom. Actually, we will write something custom. So the main YOLO repository, you're going to find a link to it in the video description if you haven't looked yet. This is it. It's called YOLO v5. There have been 5 versions of YOLO so far, and the only version that I've talked about is YOLO v1. And YOLO v1, it's not like the greatest algorithm, but it was very popular because of the name. And often, if you can think of a good, popular name for your algorithm, it's going to have more researchers and more enthusiasts that build on it. It's just like a weird fact of human nature, a weird bias that we all have built in. I can think of a counterexample to that, like latent Dirichlet allocation, LDA, is a dimensionality reduction technique. I think it was invented by Professor Andrew Ng at Stanford himself. And nobody cares about it. Nobody uses it. It was a great algorithm, but I think that the name itself is just so random. What does that even mean? What is Dirichlet? Anyway, so naming your algorithm can, definitely get you points. Just something to note. Anyway, so, and by the way, this algorithm, what also makes YOLO so cool is it was created by a bunch of independent developers. This is a great tutorial, by the way. Like, definitely read this article by Amro Kamal. What makes it so great is it was just a couple of independent developers. It wasn't Google. It wasn't Apple, Facebook, Amazon. It was just some indie devs who decided that, hey, we want to create a custom algorithm, and we're going to call it YOLO. And it outperformed everything else. So that should be inspiring to you. You don't need to be a part of them, the big corporations, to come up with these techniques. So in this YOLO v5 algorithm, what have they done? They've added a bunch of things. They've, since YOLO 1, YOLO 2 added on this idea of the bounding boxes were not, they were not accurate enough. They were not, the bounding boxes were just all over the place. And so what YOLO v2 did is it made those bounding boxes better by creating a set of what's called anchor boxes. I think that's what it was. It's called like anchor boxes. And basically that idea of anchor boxes said that the network design is going to, the fourth term, YOLO v2, yeah. Yes, anchor boxes. So like, if there are images that are within a grid, so first of all, YOLO creates a grid, and then inside of that grid, if there are multiple objects that are detected, there can be a problem. So like multi-object prediction per grid cell is a problem that YOLO v2 solved, where it said that, okay, even though these images are very close together, which the original YOLO algorithm had a problem with, in this algorithm, we're going to be able to detect those images even if they are close together, because what we're going to do is we're going to add what are called anchor boxes, which are not directly computed from the pre-trained convolutional network. They are just randomly added to it. And those anchor boxes are then made more accurate using k-means clustering, right? This has nothing to do with neural networks. This is just a clustering algorithm. And this is what was used in YOLO v2. So essentially the pipeline became convolutional network, k-means clustering result. So it's not some kind of super elegant end-to-end solution already with V2. There's already some other ML technique tacked onto it. And those location coordinates are here as this math equation. But, that was essentially the big thing for Yolo V2. And then Yolo 9000 basically added the ability to detect more than 20 classes. So multi-class detection, more than that. And how did it do that? It built this word tree. It built its own custom word tree. And honestly, language is the key to unlocking general intelligence. Language is everything. Seriously, like I love language. Linguistics is my thing. Both human languages and machine languages are the key to intelligence. And essentially this structure right here of this word tree that they built, this specific word tree, encoded all of these custom classes specifically for multi-object detection, not just for classification. So often when you want to create a solution, it's got to be something super niche. It's not going to be super elegant end to end, but at least it works, right? And that can be applied to self-driving cars as well. Self-driving cars are not end-to-end right now. That means there's not just one deep neural network that does everything, but it's still very accurate and it's still doing life or death predictions. Eventually, I hope and we all hope that everything's going to be end-to-end, and it will be. It's just a matter of more data and more computing power, I believe. And if you don't believe me, go check out GPT-3's result. Look at the graph versus GPT-2. The more compute is all you need narrative still holds true, and it will always hold true until proven otherwise. What happened with Yolo V3? With Yolo V3, they added basically more machine learning. They added logistic regression for Yolo V3 for those bounding boxes to predict where the most likely bounding boxes should be. So notice they are just tacking on these other machine learning techniques. It's not just pure deep neural networks. Pure deep neural networks, it's not going to give you the most accurate result. It's going to be the most elegant solution, but it's not going to be the most performant solution. And that was Yolo 1 through 3, and then you had Yolo 4 and Yolo 5, which are essentially much, 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 much faster. And you can just see that with this graph right here. So let's just start coding. Let me pull up a Sublime window or something now, because I want to start coding something. So Sublime, and then let's see what we got. New file. Okay. So what we're going to do is we're going to code out something. We're going to code something in Python. And what do we want to code in Python? Well, we want to code YOLO in Python. And the way we're going to code YOLO in Python is we're going to put up this coding window. And I still have this old gym repository here, but that doesn't matter. We're going to just write our own thing. We're going to run our own thing. So we got Python import. Let's see. So before we even import something, let's download this code and stuff, right? So, or at least this initial YOLO v5 repository, so we can build something custom on some custom images. Let's check this out. So, where do we want to start with YOLO? We want to start with, what do we got here? We have train custom data. So that's a great tutorial right there, train custom data. What else we have? Train custom data, YOLO, okay. Oh, they've got a collab. Oh, my favorite thing, our favorite thing. If you don't know, now you know. Collab is amazing. Okay, let's check out this collab. So in this collab, I can just test out YOLO so easily. Remove that. And test this out. Okay. So what's happening here? So the first thing that's being done is the repository is being cloned, and then we're going to install the requirements, import Torch, PyTorch. It's authored by Google, run anyway. Okay, let's run this thing together. It's downloading that repository, that YOLO v5 repository, into this custom collab notebook. It's going to install all of those dependencies one by one, and it just did that. Now we can run inference. And so it says that it's just going to run this detect.py algorithm using the pre-trained YOLO model on an image of this size with this confidence. And the source of what it's going to train on is this image right here. It's called zdane.jpg, which is going to be should be here somewhere. Sample data, Yolo v5, data. It's like one of these detect images, Zidane. This would be like right here, Zidane. Okay, so now let's run this. Let's see what that looks like. So, wow, it's so CUDA's running right here. So we've got a Tesla P100, nice GPU running remotely on Google servers. But okay, so this image, it did not have these bounding boxes before. This was just computed right now. The great thing about Yolo is that it's super, super fast. So we can do this in video in real time, which is what we want to do. So there's that. And so that was easy. That was a little too easy. We need to do something like harder than that. I don't want to, have something super. So train custom data. That's what we want to do. We want to train some custom data with Yolo. So let's just follow this thing right here. So we're going to do this locally. It says to create a dataset.yaml. This is what you guys were asking. Can we do this on custom data? That's what we're going to do. And then you have all these different models. We can visualize it with weights and biases. That's going to be our thing. So let's do that. We're going to do that now. So command prompt. And okay, here we go. YOLO, YOLO. YOLO in a bottle of YOLO. Okay. So we can clone that repository. No, I don't want to sign in. Don't ask me to sign in. No. Oh my God. See, I haven't set it up on my new gaming computer. That's why. Can I do it on Ubuntu, please? Oh, I didn't even install the Ubuntu shell on this one yet. Oh my God. See, I've been working on my MacBook. I just got back from Houston, guys. I'm like half asleep, but that's okay. No apologies, no complaints. We have training custom data. We're not going to do this on, I'm not going to log into GitHub from here. Fine, I'll log into GitHub. Let me just log in real quick. Sign in with my browser. Yeah. Mm-hmm. Good. Successful. All right, I'm in. Okay. What do you mean the repository is not found? YOLO v5? Okay, we got it. All right, now it's here. Make it bigger. Okay. All right. So that's that. Now what's next? We did that part, and now we're going to cd into this repository. So dir cd into YOLO v5, and then dir. And now we're inside of that repository, and now we're going to install our requirements, pip install requirements.txt. Very easy to do that. And now it's installing all of our requirements. And in the meantime, couldn't I fire the torch? Okay, you got to have this custom torch version, pip install torch, pip install torch. Go, torch. At least it's easier to install than no module named tools.nn wrap. Oh my God, here we go. Here we go. What was the PyTorch install again? PyTorch install Windows. See, I do everything on my MacBook, but for Windows, you just gotta install, start locally, stable. Yeah, installing on Windows was Chocolatey Python website. I don't want to install Chocolatey. Yeah, okay. What a weird name. Choco install Python. Pip. Anaconda. Where is it? What is that error? I don't want to get caught on errors here, guys. We have building wheel for torch. What the F? Okay, here we go. We're going to import torch, install Anaconda. We're going to make this work right now. Stable Windows, Conda Python 10.0. Do I have Conda installed at least? Conda? Is Conda installed? Conda? No, I didn't install this. I got to install Conda. Install Conda, Windows. I still want to waste your time with me installing everything. So I'm going to open up Sublime, and we're going to just get right into this. I'm going to just kind of write out some pseudocode of what I would test.py, what I would want to write, and then we're going to Keep going. All right. So what do we want to write here? So assume that we want to train some custom data on Yolo. So how do we do this? So I want to import Yolo detect.py import torch. So what would we want to import? Well, we would want to import torch. We would want to import like an image. What was that like image thing? Like, yeah. So I already have this right here. We can start with that. And then we will, build a model. The model is going to be torch.hub.load. And then we have some model here, model X. We'll just call it model X. So there's some model here. And then this is basically like initialize pre-trained model. It's very simple. And then the next step is to collect image data. And the next step after that, someone was, okay. I'm going to play Cyberpunk, guys. We'll end this with me playing Cyberpunk. How's that? Someone asked, I think it was related. So we have that. We're going to collect images. So image 1 equals image.open, right? So we just collect the image, test image.jpg. It can be in any format, by the way. But ideally it should be in JPEG because that's going to have the highest quality resolution, which is good for the algorithm. The most dense amount of pixels in the image. And then that's it. So that's like step 1, initialize model. Like how to use Yolo. Step 1, initialize model. Step 2, collect images. And the final and last step, step 3, predict bounding boxes. I guess we can call it predict bounding boxes, aka inference. And the way to do that is we say prediction, and then we have the model, and then we have the image. And if we had multiple, we'll just make a list out of that, and then do it to all of the list. But we just have one. I'm gonna say size equals, however big that image is. 640 is what the default example was. That is how simple Yolo is to use right here, just like that, PyTorch Hub. But there's more to it than that, and we're going to talk about what those things are in a second. But I actually now have my second question for you to ask. So let me ask you my second question. The second question is now incoming. All right. Question 2. Which of these clustering techniques has been used before in a Yolo algorithm for clustering data? Is it A, k-means? Is it B, latent Dirichlet allocation? Is it C, T, stochastic, T, distributed stochastic neighbor embedding, or T-SNE? Or is it D, principal component analysis, or PCA? These are all dimensionality reduction techniques, every single one of them. But one of them has been used before in the Yolo algorithm. Okay, so let's now see what, okay. So there was a little echo, notice that, fix that. We're working here. So let me answer some questions in the meantime. Okay, we got some seriously good questions out here, guys. I like these questions. First question is from Bruno Oliveira. How do you think Yolo v5 is compared to SSD? There's the SSD paper on archive that I was reading, and it apparently outperformed Yolo v3 on FPS and precision. Yes, it did, but that doesn't matter because now we have Yolo v5, which outperforms everything else. Tanmay Panadi asks, what is localization loss? Localization is a technique that describes the location of the object that you're trying to detect in an image. So it's like a coordinates. It's the bounding box. Pranav asks, what are your thoughts on implementing an object detection algorithm to run blood tests and detecting cancerous cells as a super cheap alternative to traditional methods? Okay, that is the future. Like, any of these voice detection, any of these like voice-enabled AI bots, Google Now, Alexa, whatever you have, right now you ask like, what's the weather today? Or, how old is X? Or what's the president of the US or something? In the future, you'll say, hey, Alexa, sorry if I, set off your Alexa, but, hey, the algorithm, my stomach hurts, my ear hurts, and I ate something bad yesterday. And then it'll ask you, well, what did you eat? Oh, I ate that. Okay, your diagnosis is X, Y, and Z. That's the future of these algorithms. They're going to give us medical diagnoses automatic. And Yolo is one, version of that. I went to the dentist 2 weeks ago. I paid $1,000 for a deep cleaning for my teeth. You know what this trained professional did? He came over and, I also had to, that has nothing to do with the algorithm. What has to do with the algorithm is the x-rays and the analysis that the dentist did. That can be done using an algorithm. An algorithm can tell you what parts of your teeth need to be fixed. Algorithms can do everything. Everything in medicine, algorithms can and eventually will automate. Everything that can be automated will be automated. And we must automate everything, because that's the only way we get to a future where all of us are creative and happy and not chained to labor. We want to free humans from the shackles of labor and move into a futuristic society where we are all living our best lives at the top of Maslow's hierarchy of needs. Suhail asks, what are your views on Uber knocking out a pedestrian? Suhail, however many times an algorithm knocks out a pedestrian, 100 million times more humans knock out pedestrians. So I think algorithms are much better, and I feel much safer with algorithms driving. Naoda Isakari asks, how are our brains so good and so efficient at these recognition tasks? What a great question, and something that I think about so often. Often in programming and coding, it's always the most elegant solution that wins, right? Like if you've ever made anything like a web app or a mobile app, you'll start with your first version. It's all hacky and stuff. But as you improve, you find that the better algorithm doesn't require as many little added on techniques. It's just very simple. And so I think that applies to our brains. We think that it's something super complicated, but it's actually super simple, I think, under the hood. We don't know what it is, but that's just my hunch. I just think under the hood, there's like one learning algorithm, and it's so beautiful and it's so elegant, and we're getting closer and closer to it every single year. But from that learning algorithm emerges all of this complexity. And I think that we're on the right track with deep reinforcement learning, convolutional networks for image recognition, and then reinforcement learning for creating a decision process to allow this real-time training loop to occur. And, OpenAI 5, Alpha 0, Lila 0, everything coming out of DeepMind. They're great starts, but there's just something that we're entirely missing. Which honestly, I think it could just be hardware. Maybe it's not even software. Maybe it's like we need some different computing medium, like neuromorphic computing or, a molecular computing. Nerd asks, good name. Nerd asks, how do you get a job in machine learning? Project ideas? This is what we've been doing on this channel. How many people here have gotten work from my videos? How many people have gotten work from my courses, from all this stuff? Many, many people have gotten jobs. The idea is that no matter what people tell you, you can learn things much faster than they say you can, all right? You've got to watch videos. You've got to play games. I've made 400 videos on machine learning, right? Machine learning is so embedded in my psyche, in terms of like how to teach machine learning fast and easy. It's so embedded in my psychology that I'm like bored with making videos now. I got to take it to that next level, a video game. And I'm telling you, you are witnessing the future of education right now when I tell you that the future of education is gaming. People will play games to upskill themselves. Yes, in machine learning, we're going to start with machine learning, and we're going to do it for everything, for all skills. We're going to do skill training. We're going to gamify all skill training eventually, even medicine. But that's, years from now. But one more question. Can you ask him what IDE he uses? I use Sublime Text. I always have used Sublime Text, but I want to use a different one. Let's see what the answer was. The answer to this question was K means clustering. 28 people got that correct. That's what I like to see. Great work, guys. 28 people got that correct. And that's what I like to see. Good. Let's play some sound effects. Oh, why is there a rap playing? No, not the rap. Need the sound effect to play. Good job. All right. So, guys, I just decided that I want to show you guys me streaming Cyberpunk. I really hope this works. This is such a huge like GPU intensive game. So let's just like get straight to the second question. And then I want to stream Cyberpunk for you guys. Now, before we do that, let me just say another thing. The reason I did YOLO for this live stream is because I like walking the walk. I don't just like talking the talk. I genuinely enjoy incorporating machine learning into my day-to-day life. And I just started picking up snowboarding, and I had this idea like, what if there was this augmented reality goggle that you could use, put over your eyes, and that could basically help you detect obstacles, and so you could snowboard better. It doesn't exist yet. Snapchat has Spectacles 3, version 3 out. They're like $400. They're not really snowboarding goggles. And so my idea was just like strap a GoPro on, take some video, go back home, run the YOLO algorithm on it. But ideally, it's happening in real time. And for that, we would need like a Raspberry Pi or some sort of onboard computing device to in real time be computing this. It doesn't even necessarily need Wi-Fi, just Wi-Fi if we want to live stream. But that was just the first version. Yeah, I think we should all be using machine learning in our day-to-day lives. To make our lives better. Like, we need to lead by example, right? Show people that AI is everywhere. AI drives my car now. AI drives my car. AI helps me snowboard. AI is helping me with gaming. It's helping me with learning, in the form of algorithms that curate content for me. It's everywhere around us. And so let me ask you this last question. Before I ask you this last question, I want to say that the YOLO algorithm was built initially in C, but then future versions use Python. That's just a hint for this question. So, last question. The last question is, which of these convolutional architectures did not inspire YOLO at all? Is it A, LightNet? Is it B, DarkNet? Is it C, RetinaNet? Or is it D, ResNet? And then we're going to stream Cyberpunk, all right? I hope the Cyberpunk works and it doesn't like lag out of this entire stream because it's so... I have everything set on ultra settings, so it's dope. So while you guys answer that question, let me answer 2 more questions. Mohammed asks, what are your views on Oracle leaving the Bay Area? Guys, I just visited Houston and my parents are all like, you need to move to Austin. Everybody's moving there because the tech companies are moving there. And it's true. Tech companies are moving out of the Bay Area. But then again, I have friends in the Bay Area who are like, now the younger generations, the Gen Z mafia, all the kids who can't afford that super high rent because now it's cheaper in the Bay Area, they're going there. And also, they don't care about Oracle. Who cares about Oracle? Oracle is some old database company from like 1 million years ago. The future is not Oracle. The future are these startups that are started by the youth. And the future Oracle might just be in the Bay Area right now. So I think that Austin is definitely, gaining ground, but it's still not any Silicon Valley. And most of the guys, the older guys who left Silicon Valley, as my friend Richard said, they just left because of taxes. And they're saying like, oh, it's the end of the Bay Area. Mostly it was just for taxes, but they're just not being honest about that. So that's why you see older people, venture capitalists, just leaving the Bay Area in droves. But younger people are moving in. So just look at where the young people are moving, right? Another question. Bruno Oliveira asks, do you think YOLO is mature enough to be used in object detection for self-driving? I would love to see under the hood of what's happening in the Tesla, but I think YOLO V5 is pretty good actually. I would use it. I mean, I wouldn't put it on other people, but I would definitely use it. I would feel safe I personally would feel safe using YOLO V5 for real-time driving. It's that fast. It detects that many things. In fact, it's almost like overconfident. It'll detect too many objects. So that's a good thing. You want to be overly safe when you're driving. Last question before we get to streaming. Pranav Desai asks, once AI becomes conscious enough and develops a sense of identity, can you blame the AI if it goofs up in a court? Pranav, if you haven't read Metamorphosis of the Prime Intellect, let me say it again. Metamorphosis of the Prime Intellect. Read the whole thing. The beginning is going to be kind of graphic. So if you're under age, if you're under 13, don't read it. But if you're over 13, you're fine. But the middle part is the just beautiful part where the AI becomes this like super intelligent AI and rewrites the operating system of the universe because it's so powerful. If the AI becomes conscious enough, there's nothing we can do. Like, it's now God and it will decide everything. And it's like this benevolent AI overlord. So it's not a question about courts. The idea of the legal system, the idea of courts themselves becomes irrelevant when we have this super intelligent AI. It will give us answers to questions we didn't even know to ask. The unknown unknowns of life. There exist concepts out there like music or like math that we are just not capable of understanding. Our brains are just at too low a level in the intelligence hierarchy to comprehend these concepts that are beyond the grasp of what we humans can. But this AI can help us when we develop it. And so religion is generally a tool that is used to oppress people, but the new religion is just about technology and, that's it. Let's see what the answer was. The answer was A, LightNet. I'm actually surprised that this was not an easy one for you guys. I thought this would be like an easy one, but I guess not. That's fine. It's great work. Great work. Let's see who the winners are before we get to the Cyberpunk streaming. Okay, so the winners are going to be I'm going to shout out the winners right now. I know you guys want to see the winners as well. So let me show you guys who the winners were. I know you guys want to see the winners. So let me put that up. Okay. So the winners are going to be transition. Okay. Until we get that custom web app, yeah, it's going to be somewhat arbitrary, like how I'm picking these people, but you can see here everybody who's answering these questions on item pool. So who got all of my questions right? Who got them all right? We have Anish. Anish Jain is the first one to get them all. Anish Jain. John K. How is it? See, I don't know how it's indexing to these people, but I'm like starting at the top. But I'm not, like if I just go top to bottom, I'll just pick the first three people who, I think that's the most fair thing, honestly, just because it's going to be arbitrary either way, just because I'm picking. So might as well just go top down. I don't know how it's indexing these. Like, is it fastest time to answer questions? It's not alphabetical. Maybe it's random. Hopefully it's random. That would be great. So I'll just go top down. So Anish Jain, John K, who won last time, and who got the next one? Yoshi City. We got Yoshi City YC right here. So those are our three winners. We've got Anish Jain, Yoshi City, and was there someone else who won? No. And John K. John K. Each of you guys wins $50 worth of Bitcoin. Thank you for playing that game. Congratulations to you guys. Let's give them all a shout out in the chat. Great work, guys. Amazing, amazing work. I'm very proud of you. You guys are my heroes. Legends never die. Okay, so let's now stream Cyberpunk 2077, shall we? So that's what we're going to do, guys. And if you want, you know the deal. Email me, hello@sirajavol.com within 1 hour from now, and then I'll give it to you within 5 hours. Sounds good? The reward. Give me your Bitcoin address, essentially. And then next week we'll have that play card out. So let's launch Cyberpunk, and let's just see how this goes. Here we go. Cyberpunk 2077. Can I even run this thing? Okay. Can I even run this thing? That would be so crazy if I can run Cyberpunk on this. That's like, okay. how do I show it? Like, it's not window capture. It's like game capture, right? Game capture. Any full screen application. Is that working? I'm not sure how to like. Okay, it's working. Yes. Oh my God. Yes. Do I have sound on this? Dude, this music is so lit. Let me turn the sound on though. Okay, so let's just I don't know if you guys can hear this. Can you guys hear this? So let's just play Cyberpunk, guys. All right, here we go. Let's play Cyberpunk. I don't know if you guys can hear this. Can you hear this? Properties. Let's just start the game. Continue. Okay, let's just start the. Hold on. Hold on. Is this working? Okay, I'm going to. Yeah. Audio output capture. Position. It's working. You guys can hear that, right? Yo. Oh my God. Look at these graphics. Look at this ray tracing and the particle effects. Look at how big the map is. Look at how many NPCs are all
45, 46. Fuck. We're still short.
Police are after me. The police warrant has been issued.
Fucking firefights!
Oh my God, there's a. I am not gonna die in my first game here. I'm not dying. Not today.
You want to smack a what?
Look at this like back alley Chinese place. Oh, don't shoot the police. I just headshot a police. I am. Where are the cars? Let me get out of here. Okay. What? Hey. Oh my God. I need this car. I can't take control. I guess I can only take control of like really bad cars. But oh, here's a really bad car. I'm getting shot.
NCPD, stand down!
Okay, get out.
Please don't hurt me!
Yep. There we go. Yes. Woo! So I can't play too much, but there I died. Okay. So that was Cyberpunk 2077. I hope you guys like this live stream. Congratulations to our winners, John K, Anish Jain, and Yoshi City. I love you guys. I'll be here next week. I'm not sure the exact date, but I will schedule something by tomorrow or the next day for next week. And also shout out to our sponsor Zilliqa for sponsoring this video. Thank you, Zilliqa. They're a blockchain company that enables us to have rewards for this community. So thank you guys. They enable me to have enough to send you guys every week. And I'm looking for sponsors as well. I want to continually up the prize pools for these weekly live streams. I'm committed and focused on that. We're going to raise that money to my ideal goal. Success is if we have $10,000 prize pools every week. Right? That is success, but we have to get there. That sounds kind of crazy right now, but that's kind of how I'm thinking about this. So, thank you guys for showing up. I love you guys, and I will see you next week. Peace.